Hi there, welcome to Unity Insights, a dedicated channel for beginners focused on teaching Unity. Today, we'll look into rigid body component. For those who are new to this channel, myself Somnath Chaudhary and I'm a professional Unity developer. Before jumping into Unity Editor, let's have an overview about rigid body. First of all, Unity's built-in 3D physics system is an integration of NvidiaPhyX engine. And due to that, it helps you in character control, rigid body physics, collision joint, etc. Let's understand the rigid body and have an overview. Rigid body is a soul of a 3D game object. So it's a magical component. Whenever you attach to a 3D game object, automatically you are adding a physics simulation to that game object. Don't worry, we'll see it in editor in details. Next, it inherits from component. That means whenever in Unity editor you create a 3D game object, let's say we are creating a sphere, and this sphere, if we are adding a rigid body component, let's add one. Now you can see this rigid body component you cannot disable, and similarly you cannot disable the mesh filter as well as the transform component because these are inheriting from core component. As I mentioned some time back, that it simulates physics without adding any script. For 3D game object, we use rigid body component, and for 2D game object, we use rigid body 2D component. Now let's dive into the Unity editor and see all of this in details. So whenever you add a rigid body component to a 3D game object, so you can see there are multiple properties, right? Let me first delete this sphere. So I have created a small environment here, right? Here I have a floor which has only a mesh collider and mesh filter and mesh render. These three components. Now to understand each properties, I have created several small game objects. So let's enable this mask and understand this. So under mask, I have kept 5 different cubes, and each cube has a different mass value. For the first one is 1, second one 5, 10, 15, 20, like that. So higher mass doesn't mean your object will fall faster. Okay. So whichever object has higher mass, you need to add more force to move that game object. Right. Let's see it in practical. So whenever you are playing it, all the objects should fall at the same time. Right. Now you can see all the objects fall in the same time. Now the object which is like 1. So this one, let me move this one here, zoom it. Now this object has a mass of 1. And the last object has a mass of 2, right? So from this object, if I try to push this, see now it's struggling to push that object which has 20 mass. But if I take the mass which is like 20, and if I try to push it, now you can see easily you can push it, right? So this is what happens whenever any higher mass game object hits a lower mass game object. Your lower mass game object will move faster. Okay. To move a higher mass game object, you need to add more force. That's about mass. Let's disable it. Now the next property is linear dumping. Okay. Linear dumping means, okay, let me stop it. Then disable the mass and enable the linear dumping. Here also I have used the same 5 cubes, right? And for all this game object, now the mass value is same 1, but I have different linear dumping value. Okay, first one is 0, 1, 2, 3, and 4. So whichever has higher linear dumping, that object will fall slower, right? So for example, here this cube has a linear dumping of 0. Okay. So whenever you are using any parachute type of game and all, so that time you can manipulate with this linear dumping. Now you can see the first game object falling faster, and like that, it is falling at slower rate, which has linear dumping 4. Right? So this is all about linear dumping, and you understood where to use it, like parachute game and wherever any object has to fall slowly. Next is angular dumping. Let's enable it and understand. So for angular dumping, it's similar to linear dumping, but here the rotation would be slower, right? So here also I have used one, so 5 different base balls. You can see. Okay. Sorry, this is the base. That means this game object. You can see this is the base, and I have 5 different spheres. Okay, and I have attached some material so that I can see the rotation speed. So now the first ball has a angular dumping of 0.05, that is like the default value. Next one I have increased it to 1, 2, 3, like that, 1, 2 and 5. Sorry. Okay, so now let's play and see what's happened. So whichever has higher value, that object will rotate slower. That means that object will roll slower. Now you can see the first object is rolling so fast, second is little slower, third is even slower, and fourth one, which has angular dumping 5, is rotating very slowly. So this is how you can use your angular dumping. Let's stop it and disable the angular dumping. Now comes center of mass. So for every game object, usually the center of mass would be in the center. I can see this is the first object and this is the center of mass, which is like checkbox is enabled. Second object, I have checkbox disabled, but I have not changed any value. That means it is also similar to checkbox enabled. And the third object, I have made the x value 1 and remaining 2 same. Fourth one, y value 1 and these two same. Next one, z value 1 and remaining 2 same. And last one, I have made all 1, 1, 1 just for experiment. Let's see what happens. So that means the center of gravity will change. For the first one, it will be center. That means it will keep standing. I can see first one was checkbox enabled. Second one, checkbox disabled, but the value was not changed. So that one still is standing. The third one, x value was 1. So that's why it fall toward the right side up. Okay. And then the next one, it is the y value 1. That means still it's the center of mass is somewhere up. Right here. The next one, where it is z value, it fall toward the z side, the other side. Right. If you have any problem to understand which side it is, you can use this navigator to understand which is x side, which is z, and which is y direction. Okay, and the last one, which has like all 1, 1, 1. Now you can see it is continuously dancing. It is trying to match up the correct center of mass. Let's stop it. Now this is about center of mass. What's next? Next is automatic tensor. So like that center of mass, it gives a point where the mass be should be. Okay, and now this automatic tensor, it is what's the rotation point, right? For example, here automatic tensor, I made the checkbox enabled. Next one, again I did the same, checkbox disabled, but value I have not changed. And here also I have just disabled the checkbox without changing any value. I'm just disabled these two checkboxes. Next one, this one I have made change in the x values. Both I kept 5 and 5. Next one, I tried making it 10, 10, the x value. Okay. Next, 15, 15, something. And then 20, 20. Okay. And here also I changed the x and what do you call x, y, z values. Right. Here all the values are changed. So now let's play and see how it's working. The tensor, the rotation angle. Now you can see it's similar to the previous one, like the automatic center of mass, but here the rotation things will keep changing because this object, it was falling in the z direction, but it was not moving. Now because of automatic tensor, this object also kept moving for some time and then it stopped. Right. So this is how you can use your automatic tensor. Let's stop it and disable it. What is next is use gravity. That's very simple concept here. Here I have two wall. Okay, the first wall, the big one, I have a rigid body. Okay, and here I have the use gravity option checked on. That means whenever my game starts, this object should fall on the ground. Next one, I don't have any, so I have disabled the use gravity checkbox. That means it is little up from the floor. You can see there's a gap, and the sphere I have, the sphere there is no rigid body, but it has a sphere collider. So now let's play and see what happens. Usually this object should fall because of use gravity checkbox. You can see now it fallen on the ground, right? Now this is about use gravity. Let's stop it. And okay, let's understand one more concept. If I move the sphere, what happens? Like this one is use gravity false. This one is use gravity true. Let's see. And if I select the sphere and try to move, now you can see because use gravity was false. So whenever any object it hits the this object, this thin wall, it started flying. That means until any external force touches it or gives additional force, till then it will be in that static mode. Whenever you give a shake or something, then it will start reacting with the physics. That's the use gravity checkbox disable option it does, right? So now let's disable it. And now next is kinematic. Is kinematic whenever, so let's see what I have done. Here I have use gravity true and use is kinematic also true for this thick wall. And for the thin wall, I have kept both disable. Use gravity false and is kinematic also false. So now let's see what happens in these cases. So let's play it once again. Now this time you can see the big wall, because this one is kinematic on, it will not fall. So that means it is disconnected from physics engine, right? But if you move, like if I take a sphere and try to move something, see it is not reacting at all with the collision as well also, right? But for this one, it's still reacting, right? Like this wall one, it has a use gravity false, okay, and is kinematic also false. Okay, that is about is kinematic. So whenever you need a object which should be static, right, it should not have fall on the ground, or maybe it should not have a gravity effect, in those cases you can use this is kinematic effect. Next is interpolation. So interpolation, okay, let's open it and see in sphere. In interpolation, you are getting three options. One is none, that means that there is no interpolation effect. One is interpolate, that means the current position and the previous position. It will try to smooth up between these 2 points, right? And exterpolation is like current position and the next possible position it will try to detect, and then it will try to give a motion. Okay, so for this ball I have attached a script here so that I can move the ball with my keyboard, right? Let's play and see. So by default interpolation value we kept it as none. So whenever it is none, now my camera snap to that ball, and whenever I'm pressing the A button, it's going toward the left, and whenever I'm pressing right button, it's going toward the right. But my camera is moving very smoothly along with the along with this sphere, right? Now let's stop it and change this interpolation to interpolate. This is whenever this is most useful whenever you are creating a camera follow option, right, with your game object. So in those cases, this option would be useful. Probably in editor, you might be seeing that with none, my camera is moving smoothly along with the object. But whenever you deploy in your device, that effect might be different. So you need to keep testing, and you need to test and see which option is like fitting for your game object, right? for your game, you can say. So now I have interpolate value. I kept it as interpolate, and let's see if I move. Now you can see my camera is shaking, right? My ball is shaking, and camera is trying to match up with the ball's current position. Whenever it's moving slowly, that time camera will nicely follow. But whenever you have a fast movement, that time you can see the jerk effect. So similarly, if I use exterpolate, that's the same thing. It will try to match up with the current position and the next position. It will try to predict, and it will try to adjust the camera smoothness. Okay, let's see extrapolate. This is also like similar kind of effect. It is like trying to, again, if it is moving very fast, it is jerking, right? You can see the jerk effect. Okay, so you can test your game and you can check which one is best fitting for you. So that's about interpolate, how smoothly you can move. Next is collision detection. So now for this collision detection, what I have used, I have a wall, okay, and a capsule, which is like a gun type I have kept. And inside this capsule, I have a point, like empty point, from where my bullet should throw, right? I can shoot my bullet. Okay, so I have added a script here, and that bullet speed I have kept as 100. Okay, is auto is none. Okay, bullet spawn point, I have given this point, whatever is my empty area it is. Okay, and this is the bullet prefab. And in this bullet prefab, if I see what is there, by double click, it's just a sphere collider and a rigid body, nothing else, right? And now in this bullet, my collision detection is discrete value. Okay, so now let's see, whenever I'm playing and whenever I'm clicking my mouse, the bullet should spawn in the like tip of this capsule, and it should throw toward the wall. So let's click. Now you can see my bullet is crossing the wall and going beyond that because of discrete. It doesn't, if your object is moving very fast, it will not detect the collision. It might not detect. Okay. So now let's take the script and reduce the value to somewhere 30 in the discrete. And let's see. Now you can see it is detecting the collision. So that means whenever my bullet is moving very fast, if my game object is in discrete collision detection, then it might not detect the collision. So what we can do in that case is, let's select the bullet prefab again, and this time I'll change it discrete to continuous. That means continuously it will keep detecting, right? So now let's play once again and see what happens with the same speed. My speed is 100 still. Now again, now you can see if I throwing very fast also, it is detecting my collision because of continuous. Next option is, there are two more options. One is continuous dynamic and one is continuous speculative. So continuous dynamics, like whenever you have a moving game object, right? That time you can use this continuous dynamic. So let's see here for this wall, I have attached a script here, right? Let's move the wall. Let's rotate toward the y-axis with the 500 speed, and let's see what happens. So now my wall will continuously, it will move, it will rotate. That means, okay. And now if I'm clicking, you can see because of my continuously moving object, right? My bullet, where is my bullet? It is continuously dynamic, right? And my next option is, double click here, continuously speculative. What this will do, so whenever you create a sphere, right, you can see there's a sphere collider. It's a green color area, it's your collider. That means whenever you are hitting any object, and till this point it will detect, like whenever you're hitting, whenever your collider and the other object is colliding, that time only it will tell you, like, okay, this is collided. Speculative, what this will do, this will create little extra space. It will calculate little extra area, and then it will tell you. So that means whenever you have a wall here only, it will detect, okay, that collision happened. Okay. So this kind of effect you can use in your car and all, car racing games and all. So that whenever both the cars are like very close to each other, that time you can show some kind of particle effect, right? So now speculative, if I do, let's play once again. So there should not be much difference between dynamic collision and dynamic speculative collision, right? So if I click, now you can see it is happening same, but it is calculating little extra. That's the difference between these four collision detections. Okay, let's close it. And now freeze option. Let's enable it. So for freezing, I have kept two capsules. Okay, let's say this one capsule. For this one, I have the freeze position X, freeze position Y, and all three rotation I have freezed. Okay, that means Unity will not calculate these values. Only it will calculate the Y values. In that way, you can save the calculation power and you can save your CPU. And the other one, this one, I have kept everything like by default, like every checkboxes are disabled. So let's see what happens. So whenever my first capsule, okay, let it fall. Okay, so now you can see the first capsule. Okay, the other side. Okay, this is the correct side. This first capsule, it touched and it fall toward the ground whenever it is, because it doesn't have any freezing point. But this one I have kept said, like, don't rotate toward the X and don't rotate toward the sorry, don't change position toward the X and Z. So let's change it. Let's stop it and then change. Let's say I'm changing the position of X, okay, and rotation also X. Let's see if it happens anything. Okay, now let it fall. Now you can see little it slided from that point, right? So similarly, if I do for Z, which side is my Z? Z is back side. I'm not sure whether it will fall or not. Let's try it. Why not to try? Okay, now it will fall, and now it is like Z point. Now you can see little it is rotating, right, toward the Z. That means toward the blue axis it is rotating, because we have just unfreeze the rotation of Z. You can see here only in the Z axis it is rotating, right? And now if you change freeze the Y value, that means it will not fall, even though if you have checked all boxes on or anything. That means this object will be in that position. The Y position will not change. That means it will not fall. It will be there as it is. You can see this object fallen, but this one it's there. Okay. So this is how you can use your freezing points. Okay, let's reset it. And the next option is your layer option. Okay, so for layer I have two capsule. Okay, and this is, okay, from this angle I'll see this is my capsule and this is the capsule one. So for capsule I have said, like, use include layer UI. Okay, whatever object is in UI layer, that I'll calculate. Okay, that means this capsule is same, and whichever object is in my layer, that calculation I'll not do in simple way, right? And the other one, this one, the second capsule, I'm doing the other thing. Whichever is in my layer, that collision I'll tell, and whichever is in UI layer, that collision I'll not detect, like that. And here I have two cube. So first cube, the backside one, it is under my layer. Okay, and the second cube I kept under UI layer. So let's see for this cube, which is like UI layer. That means it is include layer. That means it should collide with this one, but not this one, right? Let's play and see what happens. Okay, so now you can see this capsule, if I hold, which is in UI layer, I'm trying to come near to this, and now it is collided. Okay, just because it touched the other one, it fallen. Okay, so let's see from this angle, and this one I'll keep little farther. Okay, now let's see. Okay, let's hold the this cube which is in UI layer, which should interact with this cylinder or this capsule. Okay, okay, you can see here, but with this one it will not detect. There won't be any collision effect with this capsule. If I try how much ever, it will not detect. Similar, but this one has a my layer, right? So this capsule, it's saying it will include my layer but not the UI layer. So if I hold this, the other cube, this one, and try to collide, now you can see it is jumping. So this is how you can use your different layers. Okay, for testing I have used like random layers, but you should properly arrange your layers and keep objects in proper layer. Okay, I think we have covered all the properties here, and we have experimented different values. Now you can take your Unity and see which all what do you call it? Which all thing you want to test, experiment, you can say. That's it in this video. Thank you for your time and patience. Hopefully you got some insights about Unity's rigid body component. Now you can play around with different values and see which all values are best suiting for your game or application. I would recommend you to join our Unity Insights WhatsApp channel and share your queries there. See you in the next video. Till then, keep learning.